And we're delighted to have Alex Bartfeld from Cloudera here. So, Alex.
Good morning, everyone. Absolutely delighted to be here in Belfast. I want to thank Kainos for inviting Cloudera here to present today and talk to you a little bit about big data. You've just had a great introduction from a technical angle. I'm going to start with the big picture and then move back into how Hadoop actually achieves some big data strategies. So Cloudera is the leader in software and services for big data built on Apache Hadoop. I'm going to show you a little video now, which will explain a little bit about what that means. It's the moment of truth.
So when I think about what's going to be possible in the future, what are we trying to measure? Can we measure every transmission of power to every device on that utility grid? For agriculture, can we measure every seed in every plot of land on every field in the world? In the life sciences, could we measure the behavior of every cell in every living organism on the planet to create new kinds of diagnostics to identify a disease earlier? Can we measure every star in the universe? Do we have systems which will be able to contain that amount of data and allow us to ask questions over that amount of data? That's really the kind of software we're building at Cloudera. It's not just about performing complex analysis, it's about allowing you to see larger and larger populations of entities.
After that, anything I'm going to say is going to be anticlimactic. So what I thought I'd do today is actually build on some of the thoughts in that video and talk about some actual use cases for how some of our customers, and actually it's open source software, so other organizations who aren't necessarily customers are using Cloudera software across Europe. So Hadoop has developed now beyond what was probably a year ago, or maybe a bit longer, 2 years ago, more of an experimental curiosity to be, as Joe said earlier, a kind of central component of most organizations' data management strategy. The guy who was doing the voiceover on the video earlier, he's one of our founders called Jeff Hammerbacher. And he is something of an icon in the big data world. He was one of the first 50 employees at Facebook. And he's quoted as saying, some of the best minds in IT are focused on getting people to click on ads, and that sucks. And he's actually taken that thought and actually dedicated something like 25% of his time to applying big data technology, Hadoop in particular, to life sciences and medical research. The reasons why he would want to do that is, first of all, take away some of the sexy analytics, but he just wants to provide a system that will improve the quality of healthcare and reduce cost. And when you look at Hadoop technologies, the cost per terabyte, which is one metric which a lot of CIOs will be looking at, is reduced by 10 to 100 times. So maybe $100,000 to $200,000 per terabyte down to kind of $1,000 to $10,000 per terabyte. So at a fundamental level, we're putting infrastructure in that just reduces cost. once we've put in the great data plumbing, we are then able to go and do more interesting things. He's working with Mount Sinai Hospital in New York City, which is one of the top medical research organizations in North America, to introduce genomics into health records and to understand the human brain. Back in Europe, we've been talking to a cancer research center who are looking to use big data technology to look at every single cell in human tissue and identify abnormalities. They're already doing some pretty interesting stuff with crowdsourcing, but by looking at image processing on Hadoop, maybe built in with some machine learning algorithms, we think that we can accelerate that process. We've also done some work with a pharmaceutical company where they have taken all of their clinical trial data, which is mountains and mountains of data built over years and years of research, multi-format. So some of it is highly structured spreadsheets, some of it is semi-structured, some of it is completely unstructured, videos, images, PDFs. And they've ingested all of it into Hadoop, and they're now running search on that data. So one single data source, one enterprise data hub for all of their data. A UK-based energy company. I'm going to do that really annoying thing where we talk about customers in the abstract without naming them. The reason I'm going to do that is I really like working at Cloudera, and our customers don't let us talk about them. But so since 1986, this organization has had around 1,000 ships at any one time sailing around the world. Every 15 minutes, every one of those ships has pinged geospatial data to a central management system. Since 1986, not much has actually been done with that data. So the problem that this particular organization had is that the time that every day that one of those ships spends in port costs something, if I remember correctly, something in the order of $50,000 to $100,000. Because they don't have very sophisticated models which can tell them what day, what hour, what minute that ship is going to arrive in port, they're blocking off very large windows of time and spending an awful lot of money. Now, you multiply that problem by 1,000 ships. If you can just save 1 day per ship per month in port, then that is a problem that is going to save tens of millions, if not hundreds of millions of dollars every year. The other thing which I found really interesting is that a small fluctuation in exchange rate can actually make a difference to where you're going to get most value for your cargo. So to the extent that it might be worth redirecting a ship to go and offload its cargo in the UK versus the Eurozone versus the US. And they do that every day. The way they do that every day is they pick up the phone and they call the captain on his satellite phone and say, would you mind sailing to France instead of to the UK? They can now, using that geospatial data, they can build models to actually figure out, based on those fluctuations in exchange rate, what is the best place for that ship to unload. So another vertical which is also a big consumer of big data technology is retail. We did a project in January with a UK-based retailer where they did some really interesting analysis of social media data to try and understand, combined with actual transactions, what are the trends going to be tomorrow. And by looking at sentiment analysis, they can kind of build patterns of where they should be focusing their marketing campaigns, where they're likely to need the most stock, and actually, plot on a map of the UK. They actually did this while I was there. they thought that there's going to be a burst of interest in leopard skin trousers in Doncaster. I've never been to Doncaster before, but I'm told that's not necessarily surprising. But just the ability to look at that information just means that they can be much more targeted about their business and about their stock and their marketing. And they also looked at clickstream data. So they incentivized different online partners different ways to drive traffic to their site. And by looking at clickstream data, they figured out that the sites where people were actually making their purchases weren't necessarily the ones which were driving the most revenue to them, because what was happening was that they were providing incentives such that people would look for whatever item they wanted on the main website, but then they would go and Google it and find it cheaper somewhere else and just go and buy it through one of their partners. So they were able to improve the way that they incentivize their partner programs. So that's what Belfast Airport looked like about an hour and a half ago. It was pretty busy, actually. So how many people in the room are from public sector government? Okay, so a handful. Well, congratulations. You guys are the leaders in big data technology. Government is extremely advanced and leading with the defense and intelligence agencies. And taking aside the moral and ethical debates which have been happening over the last year or so around that data, it is, I think, self-evident that the ability for an intelligence agency, for example, to look at enormous amounts of data of any format and identify threats based on that data is absolutely invaluable to keeping us safe and doing their job. So insurance. This is a customer, they've actually got a big presence in Belfast. These were the awful floods which happened this year in England. And if you think about how you buy insurance for your car, for your home, how many data points is the insurance company actually looking for on you? They're pretty sophisticated, so they will know where you are, they'll know the value of your house. If you're insuring your car, they'll know whether you're male or female, how old you are, have you had any convictions previously. But imagine if you could, for example, for your house, look at years of weather and telemetric data, years of crime reports, and actually figure out a more efficient model for pricing individual insurance. Financial services. So we have a credit card company as a customer, and prior to deploying Cloudera, they were able to only analyze something like 2% of all of their transaction data in order to identify fraud. They put Cloudera in, and they are attempting to look at their entire data set of transactions going back years, if not decades. So this particular client actually was quoted in the Wall Street Journal as saying that by being able to look at fraud patterns, which if any of you have been a victim of credit card fraud, which I have and I'm sure many of you in the room have, it's often very, very relatively small amounts which will be taken off your credit card and often at familiar retailers. So either a PIN machine has been tampered with or something like that, your card gets cloned. And those are very, very hard to pick up. But you can pick them up if you start to spot that there have been, for example, duplicate transactions at the same retailer in the same day for 1,000 different customers, or looking over very long patterns of time where there might be fraudulent activity. And they've actually identified $2 billion of fraud opportunities which they've been able to save, often by actually preventing that fraudulent transaction from happening in the first place. So, in a sense, none of this is new. I mean, all of these organizations have always been information driven. They've all been heavily reliant on data. But I think what's different is that none of these use cases would have been possible using yesterday's technology and using yesterday's data management strategy. There's been a fundamental paradigm shift in the way that organizations are looking at data. And I completely agree with Joe that this is a very, very disruptive time in the world of data. Certainly in my career, the last couple of decades, I've never seen such a radical shift in the way that organizations are looking at their data management strategy. So working backwards, a little bit about Apache Hadoop. So Hadoop is, well, let's start back in 2003. Everyone knows Google. I think everyone knows Google. My dad isn't in the audience. But in about 2003, Google published a white paper which essentially explained how they managed to index the entire internet. And clearly that's a big data problem. And they did so by creating the fundamental building blocks of Hadoop, which is they call it GFS, which was the Google file store, which is now developed into what we call HDFS, which is the Hadoop distributed file store. So it is a way of storing, ingesting data and then breaking it up into small pieces, splitting it 3 ways so you have high availability, and letting it reside on a cluster of nodes, so a large collection of servers. And in Europe, at least, I've seen that cluster size range from about 5 at the smallest end, I think that might be the smallest cluster you technically could have, up to a couple of thousand servers side by side. So Google published this white paper, and incidentally, Google became an investor in Cloudera a couple of weeks ago, and so, which is really great because it's almost like big data's come full circle now. This is Doug Cutting. Doug is one of the founders of Cloudera, and he looked at that white paper and he thought, that's really interesting. I wonder if we could develop some open source software that could do Google-like analytics outside of Google. So you could apply data, big data processing to an organization's own data set. And in 2005 around 2005 was when Hadoop was actually launched. A lot of people in the room who are familiar with Hadoop will know this story, but the yellow elephant is Hadoop. Doug had a small child at the time, who's probably a teenager by now, who had a yellow elephant, and he was thinking, what do I call this piece of software? And his son came into his room with his elephant, and the elephant was called Hadoop. No one knows why, no one will ever know why. So that's Hadoop. So what is disruptive about Hadoop? Well, first of all, this technology is highly scalable. Because it sits on a large cluster, if you as an organization run out of space on that cluster or you run out of processor, you add more nodes to that cluster. It's as simple as that. And we have customers running Hadoop up to the multiple petabyte scale. So it's been tested up to very, very large data sets. Secondly, it's flexible. And just going back to, for example, the pharmaceutical example, it's flexible in the sense that you can have structured or unstructured data, You can have data of any format, text, HTML, XML, video, images, whatever. And that data can be of almost any size. Finally, it's extremely cost effective. Again, we're talking about moving the cost per terabyte down from potentially hundreds of thousands of dollars down to $2,000 to $10,000. And why is it extremely cost effective? As was mentioned earlier, first of all, it's open source. You can go and download Cloudera today for free. Just go onto the website and download it. And secondly, that large cluster of servers that it runs on, that is what our hardware partners hate it when I say this, but I'm going to say it anyway. That is commodity hardware, so it is non-exotic, inexpensive machines. So the new approach is taking the old way of looking at data management, where first of all you think about what is the problem that I want to solve. You then go and build software to solve that problem, and then you would, on an ongoing basis, move the data to that problem. Moving data is the ultimate bottleneck on any system performance. So what the new model does is it actually puts all your data into one data lake, or what we would call a data hub, an enterprise data hub. And then you bring the compute to the data. So MapReduce and other processing frameworks within Hadoop is actually taking the compute to the data and then returning the results without moving large data sets across the network. Another way of thinking about it, anyone here have one of these, an SLR camera? So a few of you. Has anyone taken a picture with that SLR in the last 3 days? Damn it. The right answer is no. Well, they have, but the way that most people take pictures these days is with one of these, which I'm guessing pretty much everyone in the room has. And why is that? It's not because it's a better camera. It's not, right? The quality of the SLR is going to be better. It's because that device, it's not the cost either, by the way. I mean, I was just in the airport and I happened to notice in Dixon's you can pick up a really high quality camera for about 50 quid. It's that it's integrated with all sorts of other applications, maps, so you know where the picture was taken, social networking sites, so you know you're able to post those pictures on Facebook, on Twitter. You're able to email them. You're able to instant message them. So it's because it's integrated. You don't want to have to move the pictures from your camera to your computer and then do things with them. And it's the same analogy. You don't want to have to move data to the processing. So the problem that we're solving is, first of all, missing data. We always say that when you're backing up to tape, it takes an act of God or an act of government to ever have to recover that data. It's very, very hard and very, very expensive. With the cost of ownership of Hadoop, one of the value propositions is that you can archive your data almost indefinitely in what we call an active archive. The time to process that data comes way down. So one of our founders, who was the head of data at Yahoo, always talks about how he had nightly batch jobs, ETL jobs running, that he could see as the volume of data grew and the type of analytics that was needed got more complex, those jobs were getting bigger and bigger and bigger, until the point where he thought he was going to get fired. And he had to find, he had a window where he had to run those jobs, and he had about 2 more weeks to find another way of doing things, and that's how he got interested in Hadoop. The cost of analytics and also the complexity of the architecture, again, moving everything into a central repository. So what did we do? Cloudera took the initial Hadoop structure, which was, as I said, MapReduce and HDFS. But then what we do as an organization is we take the open source code from Apache, and then we package it up in such a way that it's actually manageable by an organization without having to hire armies of data scientists and technology guys. We built system management tools to sit alongside it. We then discovered that customers wanted more than just batch processing, so we introduced SQL on Hadoop, which gives you the ability to almost forklift your existing SQL queries from your legacy system onto Hadoop and run your BI tools on top of it. Search, so doing, again, Google-like search on your own data set. Machine learning, stream processing. We then took the open architecture. Sorry, I'm just losing my slides here. Anyway, sorry, the slide moved faster than I thought it was going to. So I'm just going to skip through these quickly because I've just been told we're running out of time. And just talk about the journey to big data. So Jeff Hammer back on the video, and then I started with some case studies which really looked at the, what are the use cases for Hadoop, and that's because that's what is kind of interesting to hear, and that's the vision that most organizations are working towards. I would say that it's very, very uncommon that a customer will come to us and say, we want to do some sentiment analysis on clickstream on Twitter data. So please could you set up a cluster so we can do that? They're usually starting with an overall overhaul of their data management strategy, starting with simply give us some much better data plumbing. Let us put all of our data in one place so that we can archive it and actually be able to run analytics on that data in the future. We don't know what questions are going to be asked of our organization tomorrow, so we just want to make sure that we have all of our data, full fidelity. We haven't had to run any transforms on it, original data in one place. We then want to be able to run our batch processing faster, and then we can actually offload some of the workloads which are running on our high-end analytical databases and optimize those systems so that they are actually delivering the kinds of analytics that they were originally intended for. So we're not using million-pound boxes to run fairly simple batch ETL jobs. They're actually run for very high-end analytical queries. Once an organization has done that, that's when they start looking at fraud detection and threat analysis and social networking sentiment analysis, exploring the data, employing data scientists to actually analyze it and build intelligence based off of that. So I hope that was a helpful introduction to big data and Hadoop. Thanks very much for your attention.